Welcome back to our channel. Today we are going to find the forces in all the members of the truss shown in the figure below. Now, we have a very simple truss here with joints A, B, C and D. So the truss have got 4 joints in total and it has 5 members. 1, 2, 3, 4, 5. The truss is loaded with an external load of 1 kilonewtons at joint B. At A and B, the truss is supported. Therefore, we are going to calculate the reactions at A as well as the reaction at B. Support A and B are 7.5 meters apart. And then the distance from A to the point of loading is 5 meters. And please, if you haven't yet subscribed to our channel, please consider doing so, yeah? And we are going to appreciate. Now, starting point. Calculation of the size of member AC. And for us to get the size of member AC, we are going to consider triangle ACD. It is a right angle triangle. This is 90 degrees because this is 30 and this one is 60 degrees. Therefore, to get the length of AC, we are going to have 5 multiplied by cos 30. Remember, cos theta is usually given by adjacent, and in this case, adjacent is the adjacent is AC divided by hypotenuse, which is AD, and therefore we are going to have 5 cos 30, and 5 cos 30 is 4.33 meters. Therefore, the length of member AC is 4.33 meters. So you can write it there as 4.33 meters. After getting the size of member AC, the next thing we are going to do is to calculate the reactions at A as well as at B. Therefore, we got reaction calculations. Reactions calculations. Now, in this case, we are going to take moments about A. Therefore, taking moments about A, we are going to have the following. Therefore, this is going to be RB times 7.5 meters. Therefore, RB times 7.5, that is an anti-clockwise moment, is equal to this clockwise moment, 1 times 5. 1 times 5. Now, to get the value of RB, we are going to divide through by 7.5. And when you divide 5 by 7.5, that is going to give us 0.667 kilonewtons. And therefore, the reaction at A is 0.667 kilonewtons. Now, to get the reaction at A, we are going to say that the sum of upward forces, that is RA plus RB, is equal to sum of downward acting forces, that is equal to 1 kilonewtons. We have the reaction at B as 0.667. Therefore, we are going to have RA plus 0.667 is equal to 1. And that's going to be R is equals 1 minus 0.667. And in this case, the reaction at A is going to be 0.333 kilonewtons. Very good. Therefore, and light there 0.333 kilonewtons. Now, after getting the value of the reactions, the next thing will be determining or considering the equilibrium of various joints. Considering the equilibrium of various joints. And in this case, we are going to begin with joint A. Therefore, we got joint A. Now, plotting joint A here, we are going to have the joint. This is joint C. That's joint C. And then we got joint D there. Then this is joint A. And at joint A, we have a support whose reaction is 0.333 kilonewtons. Angle CAD, that is 30 degrees. Let's say that on member CA, we have a force F1, that is member 1, and on member AD, we say that we have a force F2 acting on that member. Now, we are going to begin with resolving the forces vertically, vertically, and applying this principle of summation of all the vertical forces being equal to 0. And therefore, vertically, we are going to have F1 sine 30, F1 sine 30 plus the reaction at A, which is 0.333 is equal to 0. We have an upward acting force of 0.33 kilonewtons at joint A, and to make this F1 vertically, we are going to have it as F sine 30. I think we explained that in our previous video that we did. So if you haven't watched it, please consider doing so that you understand why we got it as F1 sine 30. Therefore, this is going to lead us to F1 sine 30 being equal to, taking 0.33 the other side of the equal sign, that's going to be negative 0.333. To get the value of F1, we are going to divide through by sine 30. So divide both sides by sine 30. And therefore, when we divide 0.333 divide by sine 30, that's going to give us a force of negative 0.666 kilonewtons. And we say that negative shows that that force is compressive. Therefore, it means that the force F1 is compressing joint A. Therefore, we can ignore the negative and write that force as 0.666 kilonewtons into bracket a compressive force. Compressive force. Therefore, that is the value of F1, that is the force that is acting on member AC. Now, after resolving the forces vertically, the next thing will be resolving forces horizontally. Therefore, we got it as resolving the forces horizontally and applying the principle of summation of all the horizontal forces being equal to 0. Therefore, horizontally we have F2 acting away from joint A, and let's have a force F1. Now, the force that will be acting horizontally again at joint A is going to be F1 cos that. F1 cos that. Therefore, the summation of these two forces is going to be 0. That is this principle, summation of all the horizontal forces equal to 0. And therefore, we are going to have F1 cos 30 plus F2 is equal to 0. Now, at this point, we have the value of the force F1, which is negative 0.666. Therefore, substituting here, we are going to have negative 0.666 cos 30 plus F2 is equal to 0. Taking this side of the equal sign, we are going to have the force F2 being equal to negative, not negative, the negative is going to change to positive when it crosses this side of the equal sign. Therefore, F2 is equals 0.666 cos that, and that's going to be 0.577 kilonewtons, and the force being positive means that it is a tensile force. Therefore, F2 is a tensile force. A tensile force, meaning that this force F2 is acting away from the joint B, the joint A. It is pulling it in that way. Very good. Now, after we are done with joint A, the next joint which we are going to consider is joint B. Therefore, we are going to write here joint B and we analyze it. In the same way, we are going to begin with resolving the forces vertically, and applying this principle, summation of all the vertical forces equal to 0. Now, resolving the forces vertically, now we are at joint B. We can draw it here, the joint B. So joint B, we got the following. We have a reaction. So this is joint D, this is joint C, and this is joint B. Angle DBC is 30 degrees. Let's say we have a tensile force here. that is member 5, and therefore we are going to have F5. On member CB, let's assume we have a tensile force, calling it F4, because that is member 4. Now, resolving the forces vertically, therefore here we have F4. This is going to be F4 sine 30, a vertical force. Therefore, we are going to have F4 sine 30 plus the reaction at B is 0.667. Therefore, F4 sine 30, downward acting force, plus RB, which is 0.667 kilonewtons, is equal to 0. And it's going to be F4 sine 30 is equal to, taking positive 0.667 this side of the equal sign, that's going to be negative 0.667. Dividing through by sine 30. Divide here by sine 30. Divide the other one by sine 30. That's going to give us a force F4 being negative 1.334 kilonewtons. And it being a negative force, it means that the force is compressive. Therefore, we can ignore the negative and write it as 1.334 kilonewtons into bracket compressive force, because it is a negative force. Therefore, our assumption of F4 being compressive is very correct. Very good. We are still moving on very, very well. After resolving the forces vertically, we are now going to resolving forces horizontally. Resolving forces horizontally and applying this principle of summation of all the horizontal forces being equal to 0. Now, horizontally, we are going to have F4 cos 30. And therefore, this is going to be F4 cos 30 plus F5 is equals 0, both being horizontal forces. We got the value of F4 as negative 1.334, therefore negative 1.334 cos 30 plus F5 is equals 0. Taking this the other side of the equal sign, that's going to be F5 is equals 1.334 multiplied by cos 30. And that's going to give us an F5 being equal to 1.155 kilonewtons. And this force being positive is going to be a tensile force. Therefore, F5, it is a tensile force pulling joint B, or acting away from joint B. So we are done with joint B, and we got the forces acting on member BD as well as BC. Finally, our last joint is going to be joint D. And try to plot joint D here. We are going to have the following. we have a load of 1 kilonewtons acting at joint D. This is joint A, that is joint C, whereas the other one is joint B. The angle ADC, that's 60 degrees. 60 degrees. We have the force on member DC, that is F3. We have the force on member DA, that is F2. And we have a force on member DB, that is F5. Now, the force that we want here is F3, and therefore we are going to have resolving the forces vertically. Resolving the forces vertically, we are going to have the following. Now, this force at or this rod subjected at joint D is acting downwards, and the size of that load is 1 kilonewtons. Now, another vertical force acting downward will be F3 sine 60. Therefore, we are going to say that F3 sine 60 is equal to 1 kilonewtons, because these are the forces that are acting towards the same directions. And therefore, to get the value of F3, we are going to divide through by sine 60. Divide through by sine 60. And therefore, the value of the force F3 is going to be 1.1547 kilonewtons. And this force, being a positive force, is going to be a tensile force. Therefore, we are going to change that force from being compressive to tensile. That is, it is pulling joint D. Pulling joint D. Therefore, ladies and gentlemen, that is how we calculate the forces acting on all the members of this simple truss that we got at this point. And therefore, the forces acting on all those members will be as follows. On member AC, we got the force F1, which is 0.666 kilonewtons, and in this case that is a compressive force. On member AD, we got a force F2 whose value is 0.577 kilonewtons, and in this case a tensile force, positive. On member BD, we got a force F5. Whose value is 1.155 kilonewtons, which is a tensile force. On member BC, we got a force F4, whose value is F4, that is 1.334 kilonewtons, and it is a compressive force. And finally, on member DC, we got the force F3, whose value is 1.1547 kilonewtons, which is a tensile force. So thank you for watching our video. Please don't forget to subscribe to our channel, and we are going to move this channel to the next level. Let it be the greatest or the biggest structural engineering educational channel in Kenya, in Africa, and later on globally. Be blessed.